In this video, we will look at defining our own functions. When writing code, you will often be calling the functions from various built-in or third-party libraries. These functions provide a lot of useful functionality. But there will always be a need for other specialized functions. The ability to create your own custom functions is a powerful feature. Such functions are often called user-defined functions. The implementation of the user-defined functions can call existing built-in functions. In our case, those built-in functions will be various modeling functions. By calling those functions, you will be able to create your own functions that change the 3D model. Let's have a look at how to implement a function. Here is an example of a function. The way that functions are defined differs by programming language. We will use a notation that is similar to the way functions are defined in Möbius. We specify the function name first, followed by the keyword function, followed by the parameters. The function calculates the square root of the sum of the squares. The code for the function is shown on the right. The function consists of two main parts: the function header and the function body. The function body is indented relative to the function header. The function header contains the function name and function parameters. In this function, there is just have one parameter, called list. The function body contains a for each loop to calculate the sum of the squares. It then calls a built-in square root function. Finally, it returns the result with the return statement. Calling a user-defined function is similar to calling any other functions. You use the function name following by a list of arguments. In this case, we add the prefix local to the start of the function name. This is because this is the approach taken in Möbius. We have already looked at variable scope in some detail previously. Let's take a brief look at variable scope when it comes to functions. In general, the rules for variable scoping within functions is the same as in the main code section. One additional consideration is the function body is a code block. So variables declared in the function body will go out of scope when execution reaches the end of the code block. In this example, the variable called sum is declared in the function code block, and the variable num is declared in the for each code block. The variable num will go out of scope at the end of the for each block, and the variable sum will go out of scope at the end of the function block. The final line in this example will therefore give an error. When defining functions, the difference between parameters and arguments becomes apparent. In this case, the variable list is the parameter for the function. It is the variable name used in the function header and function body. The variable nums is the argument for the function. It is the value that will get assigned to the parameter. Here are two more examples of functions. Unlike the previous function, both of these functions manipulate data in the model. The first function creates a line between two coordinates, a and b. The function has two parameters. The second function colors all the polygons in the model blue. The function has no parameters. The parameter names for any function are only in scope within the function. This means that it is also fine to have multiple functions with the same name. In this example, both functions have parameters called a and b. These parameters will not interfere with one another. Next, let's look at the values returned by a function. With regards to the value returned by the function, there are a few different possibilities. First, the example here is of a function that returns no value. The function body contains no return statement. You may wonder how such a function could be useful. But the function can still make changes to the model without having to return anything. In this case, the function body contains two return statements. Once one of return statements is executed, execution will exit out of the function. As a result, for a given function call, only one return statement can ever be executed. In some cases, you may need to return more than one value. In a strict sense, this is not possible. A function can only return one value. However, that value can be a data structure such as list or a dictionary. This means that multiple values can always be wrapped in a list. This list can then be returned as a single value. On the receiving end, the list can then be unpacked to get the individual data out of the list. In the example, the function returns a list of 3 items, the start and end positions and the polyline. Lastly, user-defined functions can also call other user-defined functions. In this way, user-defined functions provide a convenient way of decomposing your code into more manageable chunks.